Hi, welcome to Physics Teacher. This video is a grade 11 physics tutorial where I show you how to find the mass defect and binding energy for any element by going over this example problem with lithium-7. Alright, so what we need to do is find the mass defect and binding energy of lithium-7 in this problem. Now, lithium-7 itself has an atomic mass of 7.01600 atomic mass units. Now, this is very important. You cannot look at the atomic mass on a periodic table. If you look up the atomic mass for lithium on a periodic table, it's a little bit less than that, because the atomic mass on a periodic table is the average atomic mass for all the different isotopes of lithium found in nature. Whereas in this problem, we are specifically looking at lithium-7. So let's write down lithium-7. So lithium-7, and it has an atomic number of 3. So the 3 tells us the number of protons. The 7 tells us the number of nucleons, meaning the total number of neutrons and protons. Since we have 3 protons, we have 4 neutrons. And for a neutral atom, which is what we're working with, the 3 also tells us the number of electrons as well. So that means we have 3 protons, 3 electrons, and 4 neutrons. So let's draw these out. Let's say just randomly we have some protons, 3 of them. We have 4 neutrons and 3 tiny electrons. Now they're just everywhere about. But if they were to come together to form a lithium-7 atom, their energy level drops and they become more stable. So if we have an energy drop due to conservation of energy, some energy must be given off. So the question is, where does that energy come from? And it actually comes from the actual mass, because the mass of lithium-7 is less than the mass of its parts. So if we were to look at that, let's look at that. So lithium-7, we have a mass of, it tells us, lithium-7 has a mass of 7.01600 atomic units. Now all these parts, if we're to look at all the parts, that is a mass of, well, we have a total of 3 protons. The mass of a proton is right here. So 1.00726 atomic mass units. And then we are going to add 4 neutrons. So that's 4 times 1.008665. And 3 electrons. So 0.000549. And that gives us a total mass of 7.058135 atomic mass units. So notice that this mass is a little bit bigger than this mass. All of the protons, neutrons, and electrons come together to form this lithium-7 atom. There's a loss in mass. And if we're to supply this binding energy, we can break them all apart again. So how do we find the binding energy? The binding energy is related to the mass loss, or the mass defect. So let's calculate the mass defect. And that's just the change in mass we have. So 7.058135 minus 7.01600. which gives us a mass defect of 0.042135 atomic mass units. And we're going to need that to convert that to kilograms. So the conversion rate is 1.66 times 10 to the minus 27 kilograms per atomic mass unit, which gives us a mass defect in kilograms of 6.99441 times 10 to the minus 29 kilograms. So there's our mass defect. So to find then that binding energy, we are going to use E equals mc squared, where m is our mass defect. So we have 6.99441 times 10 to the minus 29 kilograms times by the speed of light. So c stands for celeritas, which means swiftness, and it's the speed of light, which has a value of 3.00 times 10 to the 8 meters per second squared, which gives us a binding energy of 6.29 times 10 to the minus 12 joules. Now, if you like, you can convert this into mega electron volts, where 1 mega electron volt is equal to 1.602 times 10 to the minus 13 joules. So we just divide by that number, and we'll get this to be equivalent to about 39.3 mega electron volts.